And good morning. Here we are back to the Algebra outlet where math is affordable because I don't know where I was going with that. So here's the joke for the day. What did the lines do at the gym to avoid each other? Anyone? They used the parallel bars. Today's lesson, Chapter 4, Lesson 9, we're talking about slopes of parallel and perpendicular. So, good times shall be had by all. Please turn in your book to page 293. Parallel lines and their equations can be used to model cost, such as the cost of a booth at a farmer's market. That was for you, Liam. So, let's take a look at what we mean exactly by parallel lines. In words, we're talking about two different non-vertical lines that are parallel if they have the same slope. So if we take a look here at the graph, we see two equations, both in slope-intercept form. Now this is the simplest way we can do this. We can either see the lines in the graph, or we can see the equations. In the case where we see the equation, we know that we can put any form of a linear function into slope-intercept form. That's what we've been doing through Chapter 4. As soon as I get it into slope-intercept form, I can see my slope 1/2 and 1/2. They match, therefore we have parallel lines. Two different non-vertical lines are parallel if and only if they have the same slope. Check, check. All different vertical lines are parallel. So in the case we're looking to the right here, all different vertical lines, no matter what, and they always come in this form, x equals, we know there's no y, it's not a function, it doesn't pass the vertical line test, and we know that that value that x equals is the point on the number line where the vertical line passes through. In the case x equals 4, we go out 1, 2, 3, 4, and that's where our vertical line passes through the x-axis. X equals -2, we go -1, -2, and that's where the vertical line passes. All vertical lines are parallel. So now we have this concept of parallel. We jumped ahead here a little bit. Let's go to this one. This says, identify which lines are parallel. So let's just check. Everybody is in slope-intercept form. Every single one is in y equals mx plus b. So let's go through and extract the slopes out of each equation. And remember, we're looking for similar slopes. So the first line has a slope of 5/3. The second slope, we had this question come up yesterday. What is the slope if there's no value in front of x? That indicates 1. 1x. So our slope is 1. Our slope up here is 5/3. We can see another slope of 5/3. So we can say these two lines are parallel. And this is also in slope-intercept form. And we see that there is a single x. Therefore, we have two lines with a slope of 1 and two lines with a slope of 5/3. So we can say the first one and the third one are indeed parallel. Let's get rid of all this gobbledygook. Go back to this. So we have line 1 and 3 and lines 2 and 4. Well, let's just take a look and see. So they've got the equations here. We see y equals 1x, 1x plus 1, and y equals 1x. Well, we know this bottom line is in direct variation. It passes through the origin, so we know that's this line passing through the origin, and you see the arrow pointing to it. Y equals 1x, and y equals 1x plus 1. This line happens to have a y-intercept of +1, And if I look at both lines, I'm going up 1, over 1. Same with the bottom line. We went up 1, over 1. And we know those lines will never intersect. In the case of the second two lines, in blue to the right here, we see a slope of 5/3. The first line, a y-intercept of 4, just so that we can identify which one we're looking at. And the second line, a y-intercept of -2. And then if we check to see both lines are traveling up 5, whoop, and over 1, 2, 3, and we're back on the blue line again. And for the second, or the first one we looked at, we went up 5 and over 3, back to the line. The slope indicates direction. The y-intercept gives us our starting point. So example 1, part B, is similar to this that we're looking at here. We have, there we go, we have 4 lines. So let's decide where those begin and end at the semicolon, of course. So we're going to have the red line, the green line to there, and we're going to have the purple line. And we can see right off the bat that these are all in very different forms. The first one, or the red, in slope-intercept form. Slope-intercept. The second is in slope-intercept. The third is in standard form. And the fourth one is in point slope. And we should be familiar with all of those. The first two being very easy to graph. What we're looking for again are parallel lines. So we want to look at the slope. The first line, the first red line, has a slope of 2. We can see that. It is in slope-intercept form. So let's go ahead and write that out. The second line is also in slope-intercept form. We can see that it does not match the first line. Therefore, they are not parallel. Slope -2/3. The third line is in standard form, and what I would like you to get in the habit of doing is just solving that and putting it into slope-intercept form. Well, of course, we're going to subtract the 2x, we're trying to isolate the y value, and we're going to divide by 3. Okay, that should look familiar. So our final equation in slope-intercept form, coming out of standard form, looks like this. And now we can see purple line has a slope of -2/3. Well, so did the green line. So we know those guys are going to be parallel. And then we're going to take a look at the yellow line. It is in point slope, but we're not going to write it in yellow because that's hard to see. We have y plus 1 is equal to 3 times x minus 3. Well, remember, point slope gives us a point on the line, the x value being 3, the y value being -1, because the form of the equation is x minus x and y minus y. So we can see that plus 1 is the same as subtracting -1. And our slope, of course, is given in front of the x minus x value, this slope being 3. So we can see 3 and we can see 2, and we know those are not parallel, but we can see the green line and the purple line being parallel to each other. So let's graph the purple line. We have a y-intercept of 8/3, which is about 2 and 2/3. So we're going to plot that point, and then we're going to go down 2, 1, 2, and over 1, 2, 3, roughly right in there. So we're just going to draw a quick and not so accurate sketch of that line. That's our purple line. We see that it is parallel to our green line. This one has a y-intercept of 3. Ooh, that's really close. And then we have a -2/3 slope as well. So it's coming right along the side of that line, and my graph is far too small to see. But the fact of the matter is they have different y-intercepts, 2 2/3 and 3, but their slopes are the same, therefore parallel. Please take a look at check it out 1A and 1B and come right back here to see the solutions.